the future's calling. Maths and mind colliding. Daily dose of power. AI's here. Siyaya. Kubeka, let's learn the new way. Siyahamba phezulu. Daily dose of power. AI's here. Siyaya. Kubeka, let's learn the new way. Siyahamba phezulu.
Welcome guys to the Daily Dose of Mathematics. Today we are doing question 7 of the June 2026 Limpopo question paper. We are going to be doing 7.1.1.
7.1 is we're given.
Yeah, okay. So we're doing 7.1 and 7.2.
7.1.1,
Okay, we're going to do 7.1.1 and 7.1.2.
Yes.
Okay, we're going to do these two together, guys, and then we're also going to be taking our solutions, putting them in the senior marker. And then we're also going to be playing a song which explains what are factors and then how to factorize using what we call a table method. Okay, we can start with the first question.
Okay, we are given that f of x is equal to x cubed minus 6x squared plus 9x minus 4.
Yeah.
By which 7.1.1 says you should show that x minus 1 is a factor of f of x.
Okay, so we're supposed to prove that if we're given a linear which is x minus 1,
Yeah.
it's a factor of this polynomial. What is the polynomial that we're given? It says f of x is equal to?
F of x is equal to, let me just divide, x cubed.
X to the power of 3.
Minus 6x squared.
Minus 6x squared.
Plus 9x.
Plus 9x.
Minus 4.
Minus 4. Okay, basically, guys, if they say you are given a linear and then you're supposed to prove that this thing here is a factor, we're going to tell them, we're going to use the factor theorem. So I'm going to say using factor theorem. So use factor theorem. Factor theorem explains that if we take a linear and then we want to prove that it is a factor, we're supposed to use the root of this linear. How do you get the root of this linear? We're going to say x minus 1 is going to be equal to 0 so that we can get the x value.
Yes.
Now, if you want to do it the long way, if you want to use the long division method, it's going to take you a long time. And then if you can check the marks here, guys, it's only 2 marks then.
Yes.
So we're going to use the factor theorem. So using the factor theorem, we're going to say x minus 1 is equal to 0.
Yes.
Yeah. So we take the 1 to the other side, and then it says x is going to be equal to what? To 1.
1.
Now, how do you prove this thing here? It's a factor. We're going to take the root, not the factor.
Yeah.
We're going to take the root, and then we're going to substitute it on f of x.
Okay.
So we're going to tell them that f of 1,
yes,
close bracket. Instead of x, now we're going to put 1 again.
Yeah.
So we're going to have 1, open bracket 1, all cubed.
Yeah.
And then it says
minus 6.
Minus 6,
open
bracket 1.
Yeah. All squared.
All squared.
Plus 9.
Plus 9.
Open bracket
1. And then
minus 4.
Minus 4. Now, guys, if you type this in your calculator, if you did everything correct, it's going to give you something like. Let's type it in our calculator. Let's show them how to type it in your calculator.
We're going to have an open bracket 1, close bracket, and then we'll press this thing.
Yeah.
Will give us 3 minus 6, open bracket.
Yeah.
1.
Yeah.
Close bracket.
Yeah.
All squared.
This.
Plus 9.
And then
open bracket 1, close bracket, minus 4 is equal to 0.
Yeah. So it states that if you take any linear and then you divide it with a polynomial, the root of that thing is going to give you 0. So that's what we did here. We just showed them when we substituted the root, not the factor, we substituted the root of the linear, and then we got that it's going to give us what? 0. That was the first part.
Yes.
I'm not sure if we are going to take this to. Okay, let's take the solution to the senior marker and then play the song while we're doing that.
And guys, don't forget, remember what Mr. said when he's trying to speak slow. If today he didn't speak slow, comment not slow to prove that he's fast.
Okay.
Because you always say I'm wrong. Started to think that he's the one who's wrong.
Don't guess, don't stall.
Marking breakdown. Step. Work shown. Status. Marks. Factor theorem application. Setting x1 equals 0, right arrow x equals 1. Correct 1m. Substitution and conclusion f1 equals 0 with correct expansion. Correct 1a. Total. 2 halves. Feedback and compliance check. Caps and notation compliance. You correctly applied the factor theorem by substituting x equals 1 into the polynomial and showing that f1 equals o. Logical flow. Your layout is clean, direct, and follows the standard algebraic expectation for polynomial questions in the PhET curriculum. Coach's summary. What you did well. You correctly recognized that showing x1 is a factor requires testing the root x equals 1 using the factor theorem, and you executed the substitution accurately. Area for improvement. To ensure full marks in a formal exam setting, make sure to explicitly state your concluding sentence, e.g., therefore, x1 is a factor of f(x), right after finding f1 equals 0, as some marking guidelines explicitly allocate the final accuracy mark to this concluding statement.
Okay, now we're going to continue with 7.1.2. No?
Yes, 7.1.2.
Okay, what are we doing in 7.1.2?
7.1.2 says we shall determine the coordinates of the x-intercept of f.
Okay, so we're looking for the x-intercept.
Yes.
How do we get the x-intercepts?
We solve for x by whichever one is going to be 0.
Yeah, so we say x-intercept, we're going to start there. We're going to tell them x-intercept y equal to 0. No?
Yes.
That's where we start. Now, guys, there are many ways to do this thing. There's the long division method, there's the synthesis method, there's the inspection. It depends which one works best for you. Now, I'm going to take one which is not common, which is going to be using the table method. Now, with this one here, you just have to use your calculator. It doesn't have to be the fancy one. Any Casio calculator can do. So we're going to guide you through that one. So let's go to our Casio calculator.
Firstly, let's start by saying what our f of x is going to be equal to 0 and write the equation.
Yeah.
Because I think it's one of the important steps in this.
Yeah. So yeah, we are going to tell them what x-intercept y should be equal to 0.
Yeah.
Okay.
0 is equal to x cubed minus 6x squared plus 9x minus 4.
Okay. Now that we have this, this thing here is 4 marks. We're trying to get all the 4 marks.
Yes.
And then we're going to test the method that we're using if it's going to pass the senior mark. So what I want us to do is to go to the calculator now. And then
calculator.
And then we're going to go to mode. We're going to put it in a table mode.
Mode.
Yeah, just look for table, depending on the option of your calculator. Most of the time, it's usually on 3. What is this one saying?
Mine's on 7.
Okay, it's on 7. Okay, so just say table.
7.
Okay, from there onwards, we're going to type this thing. Remember, we should be able to type it by using alpha. No?
Yes.
So there's shift and then there's alpha. Okay?
Yes.
So we're going to tell them alpha.
Alpha of x.
Yeah. To the power.
Of 3.
Yeah.
Minus.
So
6.
just make sure that you wrote x to the power of 3. No?
Yeah.
Okay.
Minus 6.
Minus
alpha.
6.
X.
And then it's squared. No?
All squared.
Yeah.
Plus 9.
Yeah.
Alpha.
Yeah.
X minus 4.
Yeah.
Then we press equal into says g of x is equal to.
Yeah. Yeah, okay, we don't write anything on g of x again.
It's equal to.
Yeah. And then
where are we gonna start?
Where do you want to start? Let's check here. What is the last term that you see on your f of x then?
It's minus 4.
The what?
Minus 4.
Actually, it says f of x is equal to x cubed plus. What is the last thing that you see then?
X cubed minus 6x squared plus 9x minus 4.
Minus 4. Okay, yeah. So if it's minus 4, then you can take something like minus 5 to positive 5, depending on the memory of your calculator. Now, you shouldn't be shy here, guys, to test this thing here. So you can say from minus 5 to positive 5. Let's see. If we say starting from minus 5.
Start from minus 5.
Yeah.
We end at 5.
You end at 5, yeah.
Then step number 1.
This step, we're just going to leave it as 1, yeah.
Equal to.
Yeah.
Then it says minus 5 is negative 325.
Yeah. So what we're going to do, we're going to go in the side of f of x.
Yeah.
So we're going to check on f of x. We're just going to look for 0 there. For the f of x. So we're inspecting. We're just going to look on our table, which is there a place where we see our x as our f of x as 0. So just go down and check. if you go for f of, not on x, ne? On f of x, yeah. So
okay, so then the first part where f of x is equal to 0, our x is 1.
Okay, we know that one. We already know that one. Okay.
Yeah.
We're going to tell them with x is 1. So that one is a factor. We write it down.
X is equal to 1.
Okay, let's go and check if we have another one.
Then we're going to go down, 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 down. And then where is it? But again, our f of x is 0, our x is 4.
Okay, so we're going to also write 4. So we have two things now. We have x is 1 and x is 4. No?
Yes.
Yeah, you need only 2. For this method to work, you just need only of the 2 of them. And then this method is going to work from here onwards. Okay, now that you have this, you are going to go back and say to them, okay, remember this thing here is a cubic function. The cubic function is supposed to have 3 brackets.
Yes.
You already said 0 is equaling to,
yeah.
You already said 0 is equaling to x cubed. Now we're going to open 3 brackets. I don't already know what are the answers. Huh?
Okay, let me just, x is equal to 1, and then x is equal to 4, write them aside.
Yeah, you just put them just below here. Your next step after 0 is equaling to,
yeah.
You are going to put your 3 brackets there.
Okay.
On your 3 brackets now, this one here is a root. Like x is 1 is a root.
Yeah.
But factor, remember we already saw from question 7.1.1 that if it's a factor, it's not going to be x plus 1, it's going to be x minus 1.
Okay.
So I'm going to write that one. I'm going to say it's x minus 1. It's fine. Okay.
Yes.
The other one, it's x is equal to 4. It's a root. Okay?
Yes.
Now when we take it up there, it's going to say that it's x minus 4. Okay, now the problem is that you are asking, Mara, there's still a person here that is missing. Can you see that? Okay?
Yes.
We don't know what is that person. So I'm going to say, but this thing here is a cube. Obvious, we know which the first bracket is on the first part is supposed to have x.
Yeah.
Sharp, okay?
Yes.
Now, how do you get the last thing here? You are going to check what is your last term, which is your d. Ne?
Yes.
Now, we're going to say, if I say minus 1, I think the first one says minus 1. First bracket.
Minus 1.
Yeah, I'm going to say first bracket, just do it with an arrow so that you show them. How do you get that the last part? So you say minus 1.
Minus 1.
Multiply by minus 4.
Okay, minus 1 multiplied by minus 4.
What do I get?
Positive 4.
Positive 4. What is the value that I should write here such that I get minus 4? I need to get d as minus 4. I shouldn't get d as positive 4. So what should I write? I already have x.
Yeah.
So what is the value that I can write here such that I'm going to get minus 4?
Minus 4.
Huh?
Positive 4, I mean.
Huh?
Positive 4. You said what is the
Remember, okay, we have x minus 1 again.
Yeah.
That is the first factor.
Okay.
Second factor is x minus 4. That is the second factor.
Yeah.
Now, we don't know the third one. We're going to get the third one. I'm saying to you, how do you get the third one? We know which, if I say x multiplied by x is going to give me x cubed. That one is fine, okay?
Yeah.
Which is what I'm looking for. Now, how do I get the last part here? I'm saying I need to know what is the percent that I can multiply with this positive 4 that I just got so that I can put it here so that it can give me this minus 4.
Minus
4. Yeah, so it means what I'm going to say the last bracket is going to be x is minus 1. Now you can see minus 1 is repeating itself 2 times again.
Yeah.
So we have x is minus 1. We also have x is what? It's minus 1.
Yeah.
So when you're going to write this thing, then we're going to say, okay, I've already factorized that.
Yeah.
Therefore, it means my x is going to be equal to 1. My x is also going to be equal to 1. And then my x is going to be equal to 4. Now, what does this mean for Elena? Elena should remember, if a root is repeating itself 2 times, it means it's also an x-intercept. Also, it is also a turning point. So when the learner goes to the turning point next time, they know which one of the values of the turning point is going to be equal to x is equal to 1. Because the x minus 1 is repeating itself 2 times.
Yes.
Does that make sense?
Yeah, it makes sense.
Okay, so this is an inspection method, guys. Just comment if you like this method, if you want to use it so that I can teach you more. Because another learner can ask, what happened if said there was a squared here? Let's say which we had 2x cubed.
Yeah.
I can already said x and x. Now I was going to ask myself, what is the value that I should put here such that it's going to give me x cubed? So the only values that I'm concentrating on is the first value, which is a and d, when I get the inspection bracket.
Okay.
It makes sense.
Yeah, it makes sense.
Okay. So we're going to put this in a test so that we can see how do they mark it at the marking center. Will you survive if you write it something like this in the marking center? So play the song and then just go and put it in the cinema. Okay?
Guess don't stall. Take the root of the bracket, let the value fall. Let the value fall. let the value fall. Substitute it in, watch the numbers play. If it equals 0, it's a factor all the way. Factor all the way. Factor equals 0. That's the golden rule. The golden rule. The factor theorem is your mathematical tool. Mathematical tool. Yeah, we cracking the code, some Zanzi
Marking
style.
breakdown. Step.
Yeah, we
Work
finding
shown.
the root.
Status. Marks. Method for intercepts. Setting y equals 0, x, text, int. Let y equals 0. Correct 1m. Factorization 0 equals x1, x4, x1, or x1 squared, x4. Correct 2m, a. Final coordinates. Stating x equals 1 and x equals 4 without coordinate format. Incorrect format, partial 1 ca. Total, 3/4. Feedback and compliance check. Caps and notation compliance. You correctly identified that y equals 0 for x intercepts and successfully factorized the cubic polynomial using the result from the previous question. However, the question specifically asks to determine the coordinates, which means your final answer must be written as coordinate pairs, x, y, rather than just solving for x. Additionally, writing x equals 1 twice is redundant. A turning point on the x-axis is typically noted as a repeated root or dual intercept. Logical flow. The progression from 0 equals x cubed 6x squared plus 9x4 to the linear factors is clear. Coach's summary. What you did well. You successfully factored the cubic expression using synthetic division or inspection based on the factor, x1, found earlier, correctly finding the roots x equals 1 and x equals 4. Area for improvement. Always pay close attention to the phrasing of the question. When an examiner asks for coordinates, make sure your final answer is expressed as points in the form 1, 0, and 4, 0, to avoid losing the final accuracy mark.
See a bonga for pulling through the lesson. Hope you caught that daily dose of magic. Like the video and leave us your thoughts. Your comment counts, tell us what you need. Your comment counts, tell us what you need. Find us on TikTok and Facebook. The daily dose of mathematics is the handle. Hit our WhatsApp for the daily prompts. Get more info on 0664 682 9994. 064 682 9994.